Okay, these are the answers to the 2012 calculus paper. Before we begin, I just want to make a relationship between distance, velocity, and acceleration clear. Derive distance gives you velocity. To derive velocity gives you acceleration. To integrate acceleration will give you velocity. And to integrate, anti-differentiate velocity will give you distance, always with respect to time. So our function v is a function of time. Now I'm going to go through and do this paper in two different parts. I've tried to put it on a lower resolution, so hopefully it's not as jumpy when I write. Now we start with a function here for question 1a. It says find the gradient. The gradient function is the derivative of the original function. So we'll go ahead and derive that. F prime of x. It's always a good idea to write your equation as a function of x, so that when you have to put in x is equal to a value later, you can substitute x in for 2 and it'll make it clear what you're doing. So f prime equals the power goes to the front, 3 times 2 x to the power goes down by 1 minus 10, so that's equal to 6x squared minus 10. Now, like I said, f prime of 2 equals, and now we just write a 2 everywhere we see an x. The gradient of the original function is equal to the gradient function at 2. So the gradient of this equation here, when x is equal to 2, is 14. Right. For function p, and we're given p prime, that means if you want to find p, you're going to have to go backwards. We're going to have to integrate. So I'm going to integrate function p prime for x. So if I integrate 4 minus 6x squared, the power goes up by 1 and we divide by the new power. So the power of x here goes from 0 to 1, divide by 1, minus 6x to the power of 3 now, divide by 3, plus c. Right, don't forget your plus c. So this is our equation p of x. No longer p prime, but p of x. We know that p goes to the points x is 2, y is 5. Or p of x is 5. So the function is equal to 5 when x is equal to 2. Okay, hopefully that was easy enough to follow. I've substituted in x is now 2 and our function p was equal to 5 when x was 2. All I did then was solve for c. C is 13. Therefore, take this, put it back into this equation. P of x equals 4x minus 2x to the power of 3 plus 13. Okay, here we have a kinematics problem. You can be almost certain that there will be kinematics problems, more than one, in the exam. So the relationship between distance and this equation velocity, and we know that distance derived gives you velocity. So the distance s of a tractor from a post in meters is modeled by that. So there's your distance equation. It's in time of seconds since it passed the gate. So we start from time is 0 and we start from the distance being 0. So to get from distance to velocity, which we're trying to find out, we have to find the velocity of the tractor. We're going to have to derive this equation. Velocity is equal to distance timed. Therefore velocity is equal to okay, so there's our velocity. We have to find when in seconds the velocity of the tractor is 8. When is the velocity equal to 8? So what t value gives us velocity is 8. All I've done here is solve for t. T is 15 seconds. We need to write seconds as well because it's our units, and I almost forgot.